All right, so let's start. We're going to be dividing polynomials, but I am going to start with regular old division because I want to show us something that you actually already know how to do what we're going to do today, but we need some quick reminders of some things. First of all, let's just divide some numbers. Let's take 568. Oh, I'm not on the screen. All right, so now that we are up on the screen again, I'm going to do just some regular old math. I'm not going to introduce anything. I'm going to take 568 and I am going to divide it by 8. Now, here's what I want to do. There's nothing new about that. This is something that you could have done before, but let's talk process. Here's what I want. I don't care about the answer because we can get to the answer. I mean, yes, we need the final answer at the end, but let's talk about how we answer this question. Like, what is it that we do to figure out the answer? Imagine I've never done this before and you're explaining it to me. How would you explain it to me? Because this is going to help us in how we're going to do the next thing. What would you tell me to do? Yes, ma'am.
Okay, I'm not good at this, but I wouldn't do 8 divided by 5. I would do 8 divided by 56.
Okay, why would you do that? I agree with you. Why would you choose that? 8 does not go into 5. It goes in there 0 times, but it does go into 56. How many times does it go into 56?
7 times.
It goes in 7 times. So I write that 7 right up there. Now, you might be like, I know this. Why are you showing this to me? Because I want you to see the steps that you are doing automatically, because those same steps are going to be the steps that we are going to do when it comes to dividing polynomials. So I'd get on the notes. All right, so what is my next step? Now that I have a 7 up there. Yes, ma'am.
We're going to add 0. Wait, no, never mind. Wait, 8 goes into 8. So
That would actually is not my next step. Yes, ma'am.
You would write like 56 minus 56.
Why? Why would I write 56 down there?
Because that's like 7.
Oh, because 7 times 8. I'm being annoying here because I want to show you something that we're going to do when it comes to polynomials as well. So 7 times 8 is 56. That's why we do it, right? Okay, so, and I subtract those two numbers, yes? Okay, and I get 0. And I have to bring this down. And I get 8. 8 goes into 8 one time, and 1 times 8 is 8 with a remainder of 0. Now, you might be like, why did you just waste our time doing that? Because when this gets really ugly looking in a minute, you're going to see that the same steps you did here is the same steps we're going to do when it gets ugly. There's just one little add-on, and it's super easy. So we are going to be dividing polynomials. When you divided numbers, you did these steps. But when we divide polynomials, we're going to do something very similar. Now, again, even though you've got the notes that are filled in there, if I accidentally gave you those, I'm going to ask you to take your own notes here because only by doing it will you see how to do it. It's very easy to nod your head at a math teacher and be like, yep, that makes sense, totally get it, yep, I got it. But then you have to do it and you haven't tried it. So let's take a look down here at the very first one. So here's what I want us to do. It is this top number divided by this bottom number. I shouldn't say number. Polynomial divided by the other polynomial. So what I'm going to do is I'm going to set it up just like division. If this were 56 divided by 7, I would write that like this. Okay? That's how I would write it. So I'm going to do the same thing here. So I get x to the third power minus 5x squared plus 4x minus 2. Okay? And I'm about to do some division. And what is going to go on the outside of this? X minus 2. So setup here is exactly the same. Even if you're like, bro, I don't even know where this is going, that's okay because so far we've done everything correctly. What I'm saying is that what I would do is that make yourself some space off to the side. I'm doing the same thing that are going to be in the notes there that are written there the first time, but I'm asking you as a great strategy for you is that I'm not going to sit there and go, did you write it all yourself? But I can tell you just from experience, I'm not one of those teachers who just likes you to do things because I like taking up your time. I like you to do them if it's going to help you practice and it's going to help you get good at this. Because let's face it, a lot of you, your main goal is like, look, I just need to pass. That's all I need to do is pass the class, or I just need to get this grade, whatever it is. That's where I want you to be. So now, normally, like a minute ago, we said, how many times does this number go into this number? We did, how many times does 8 go into what number did we use? 568. We said, how many times does 8 go into 568? Now we're going to do this. We're going to say, how many times does x go into x to the third power? Or the easier way to think about it is x times what will give me x to the third power? X times something will give me x to the third power. What is that number? Yes, sir?
X to the second.
X to the second power.
What? Oh, I get it.
X, so right, here's what we've got. This x times x to the second power will give me x to the third power. I'm saying what thing would I need to multiply x by to get to that x to the third power? And that will be x to the second power. Now remember a moment ago when we put our 7 up top and you guys were like, put a 56 underneath there. And I was like, bro, why would you put a 56 down there? That makes no sense. And then you came to the thing where you go, because you have to do this. You have to multiply x squared times x, which gives me x to the third. But also the one additional step is I also need you to do this. X squared times negative 2. What is x squared times negative 2? Negative 2x squared. And take a guess as to what I'm going to do next. I'm going to subtract them. Now, please, please, please hear me this, because here's the number one mistake spot. Number one spot, for those of you who are not in your notes right now, here's the number one spot where somebody's going to make a mistake. When I subtract this, I need to subtract the first thing and subtract the second thing. It's not going to seem like a big difference on the first one, but on the second part that I have to subtract here, it's a big difference. What is x cubed minus x cubed? 0. Now, here's the part where the mistake can happen. What is negative 5x squared minus negative 2x squared?
Negative 3x squared.
Negative 3x squared. And if you're like, wait, bro, that doesn't make sense, check it out. Negative 5x squared minus a negative 2x squared plus, that becomes a negative 3x squared. Okay, remember we got to this step, and then we were like, what was our next step after that?
Bring down the rest.
Okay, so in division, we bring down next, right? We're going to bring this down.
Also, minus 2.
Sorry?
Do you also bring down a minus 2?
Not yet. Not yet. Just like you didn't bring down all the other numbers, you only bring down one at a time. Now, how many times does x go into negative 3x squared? Or, better question, x times what would give me negative 3x squared? Negative 3x. X times negative 3x will get me to that negative 3x squared. So notice, exact same process now. I'm going to clear away some of these arrows from the first round so that we don't have a whole jumble of arrows just going everywhere, because I'm going to draw some more arrows here. Yes? Because when you do division with normal numbers, you don't bring down all the numbers. You bring down one at a time. And that's exactly what we're doing. So the same rules that apply in long division, this is polynomial long division. That's exactly what's happening. The only thing that's different here is when you put a number up top and you go to multiply it to figure what number should be underneath, you have to multiply it with two things now. So check it out. Now we've got this. We said that x goes into negative 3x squared, negative 3x time. How did we know that? Well, that's a hard thing to do unless you can turn it around in your head and say x times what would give me negative 3x squared. And we agreed that that thing would be negative 3x. All right, so we go through the steps again. Negative 3x times x gives me negative 3x squared. And negative 3x times negative 2 would give me negative 3x times negative 2.
Negative 6. Oh, no,
Positive 6x.
Oh,
We're doing this. We're doing negative 3x times negative 2.
Oh, okay.
So instead of just being multiplied with one thing, it has to be multiplied with both of those things over there. So, okay, well, what do you think I'm going to do with these numbers now? Subtract them. Now remember, it's going to be like this. So negative 3x squared minus negative 3x squared. So we've got, let me just show it off to the side here. Negative 3x squared minus negative 3x squared is 0. A negative 3x squared and a positive 3x squared end up as 0. Because we are subtracting a negative number.
Wait, so if it was only positive, you would just add them?
If it was positive, we would do... Well, can we play the what if game in a minute? Because playing the what if introduces a whole bunch of new numbers that aren't actually here. So let me do that other scenario in a minute. Now we've got 4x minus 6x. What is 4x minus 6x? Whoa, I just heard a couple answers. 4x, the exponents definitely shouldn't change. It's what? 4x minus 6x. There is. Remember, we have to subtract them all. We're subtracting those two things, just like you do in regular division. So I'm sorry, a couple people have said it already, but it's also been mixed in with some wrong answers too. 4x minus 6x? Negative 2x. What is my next step after I do the subtraction?
Bring down the negative.
Bring down. We're going to go through the steps again. I'm going to erase my arrows here because I'm going to have even more arrows. So I don't want to hold. This gets so complicated with arrows if I don't clean them up. So here we go. Now I want to know how many times does x go into negative 2x? Or the better question, if you want, x times what would give me negative 2x? Negative 2. So I'm going to go through my steps again. Negative 2 times x gives me negative 2x. And negative 2 times negative 2 gives me positive 4. I am going to subtract both of those things. What is a negative 2x minus a negative 2x? 0. And in case you're not sure, negative 2x minus a negative 2x becomes positives. That becomes 0. Now we've got negative 2 minus 4. Negative 2 minus 4. It's minus, okay, minus positive 4. It's minus 4.
So negative 6.
It's a negative 6. Negative 2 minus 4 is negative 6. So what would I do in a normal problem like this if I had nothing else to bring down? It's a remainder. Okay, so check it out. This right here, I'm going to put an R right here for just a moment to remind us that that negative 6 is the remainder. So my answer is x squared. It's that thing up top. Here's going to be our answer right here. X squared minus 3x minus 2. And our remainder is going to look like this. Minus 6. Oh, you just made my heart jump, brother. Like, that is awesome. Negative 6 over x minus 2. Why the x minus 2 on the bottom? Because it's out of this. And if you're not sure why that, let me just show you something real quick. Let's do this division because this has a remainder. Let's talk about this. How many times does 6 go into 8? 1 time. What is that 2 down there? It's a remainder. 6 goes into 8 1 and 2/6 times, or 1 1/3. That's the same thing. We're doing the exact same thing here. That's 6. This was the denominator. This was the numerator. That's exactly what we're doing over here too. The denominator right here came from there. The numerator is right there. That's only one problem. I do not think that you've got it after one problem. This takes lots of practice. So we're going to do these exact same steps a bunch of times. Let's go to B. We've got 2x squared plus 7x plus 7 divided by x. My voice or just the tone or the pace at which I'm going? I'm just going a little bit slower here because I know that this is frustrating. If you want, I'll just talk like a normal person. All right, let's go. So I honestly find that I do slow down when I talk when things are more difficult because I understand that they're more difficult. And so you'll see it's something about me is that when I think something is an easier concept to understand, I talk faster. When I think things are harder, I slow them down a bit. Okay. So the first thing I want to do is just like it was before. I want to know how many times does x go into 2x squared? Yes, ma'am. I just can't hear you. Sorry. 2 times? 2x. Because if you're having a hard time understanding it, basically what we're saying is x times what would give me 2x squared, and that what is 2x. X times 2x is 2x squared. Now, let's see if we can recall what I did last time. What am I going to do with that 2x up there?
Multiply by 2.
Beautiful. Well, first, we're going to multiply by x. We're going to multiply by x first. So 2x times x? 2x squared. But also, what else do I have to do?
Times
2x times 2. And 2x times 2 is? Okay, that's a positive 4x. But what do you think I'm going to do with those things? Let's subtract them. I put the parentheses around there because sometimes, if I don't, people associate the negative with only the first thing and they forget and they start adding the other one. So this reminds me that both columns will be subtracted. 2x squared minus 2x squared gives me 0. 7x minus 4x gives me 3x. Next step in division? Bring down the 7. I do it as a plus 7 because just to remind me, so I don't want them right next to each other or else it gets confusing whether I'm multiplying. Okay, now that I've brought down, what do you think, and again, I know that we're just doing this, what do you think will be my next step? Yes, ma'am.
X times y equals 3x.
Good. X, let me switch colors here. X times what will give me 3x? 3. So I'm going to put a 3 up here. After I put the 3 up there, what is it likely that I'm going to do? Yes, ma'am.
Distribute this with 3 times x is 3x.
Good. 3 times x is 3x, and 3 times 2 is a positive 6. And those two numbers, what do we do with them? Subtract them. 3x minus 3x? 7 minus 6? 1. Now, nothing else to bring down. I have a remainder. All I need to do at this point, that's how I know I'm done. Nothing else to bring down. There's a number left over. It's okay if there's not a remainder. Sometimes there's not a remainder. Sometimes things are even. I go, but let's talk about how do we write the final answer now. Yes, ma'am?
So 2x plus 3,
Beautiful.
and then 1 over x plus 2.
1 over x plus 2. It is 100% perfect. I just want to add one thing. This was a positive one, so I need it to be plus 1 over x plus 2. That's the only other thing. Because we can't just leave that sitting right next to it, or people are like, what is that? It's plus that part too. There's this whole thing plus this other little part. Yes, ma'am?
Where's the x plus 2 from?
From right here. So it's that denominator will always be the divisor, the thing that's out front. This thing out front we call the divisor. That will always be, if there's a remainder, that is the thing that will be in the denominator every single time.
Do you need to have a denominator like for these? Or no, you're going to have
If there's a remainder, you have to have one. Because it's one of what? It's like one, it's a part of what though? That's what we're looking for. Yes, ma'am.
Do you leave the answer like that or does it like
That's
a
it.
bar?
That's it. No. So I'm glad you asked that question because my son, and again, I'm not trying to be funny, is that like when I did this one a minute ago, 6 goes into 8 once, that's 6, this is 2. When you first learned division, you wrote your answers like this, 1 remainder 2.
Yeah.
But then at some point, usually by 5th grade, they stopped doing the R's. Usually in 5th grade, they were like, okay, dude, don't do that anymore. Just do 1. Here's the numerator. So, and here's the denominator right there. So it becomes 2 over 6, which can be reduced to 1 and 1/3. So I'm glad you asked the question. Don't do the R thing. That R thing is like a, hey, we know you don't know division yet, so we're introducing you to remainders. But you guys should be well past that now. So if you haven't stopped doing that, we're going to stop doing it now. Yes, sir. No? Okay. Let's keep going. Yeah. Because like sometimes when I look at polynomials and I see it all together, it looks really confusing. So if I'm doing something simple like negative 3x plus 3x, and I'm like, wait, what is that? I just write it off to the side because sometimes looking at it separately is a little bit easier. And I go, okay, I know what that is now. All right, so we're going to do the same thing for c. X squared plus 3x minus 4 divided by x plus 2. All right, what do you guys think I'm going to do first? Yes, ma'am.
X times what equals x squared, which would be x.
Good. I'm saying how many times does x go into x squared? Or the other version I'm saying is x times what equals x squared? And you said it was? X. All right? And with that x that I put up top, what will I be doing with it?
You're gonna be well, first I have to put the x in the under, yeah. And now you're gonna put x squared. And now you're gonna do x and 2, which equals 2x. And now you're gonna solve it. So it's 0.
What do you mean solve it?
So x subtract it.
Oh, okay, we're subtracting. Okay. I'm being annoying just because I want us to get used to the habit of just saying, what is it that we're doing? Bless you. X squared minus x squared
0.
is 0.
And that's gonna be a 1 plus 1.
Like this?
Yeah. Now
Something bothers me about that.
1x.
1x.
Yes, that's it.
All right. So I apologize. We got 1x there. And what is my next step?
We're gonna bring down the negative 4.
Bring down. We need this brought down.
And now we're gonna do x times what equals 1x. And that is 1.
Okay,
So
so
we're gonna do plus 1.
x times what will equal 1x? And that is, as she said, that is 1.
And now you put the arrow with the x in the top.
Okay, 1 times x is
1
1x. And 1 times 2?
is 3x. I mean 3, I'm sorry.
1 times 2.
1 times 2.
You're adding them. It's okay. It's just you're adding 1 and 2 instead of multiplying 1 and 2.
Wait,
One-
you're supposed to multiply?
Yeah.
Oh,
So what's 1 times 2?
2.
2. And now what do we do with these two things?
We're gonna subtract.
Okay.
So it would be 0 for, and plus,
So this is, and Riley, I might be wrong. This is one of those situations where I go, wait, negative 4 minus 2, like positive 2. I just write it like this. Negative 4 minus positive 2, like that. Like I'm about to do that off to the side. It looks a little easier to me when I separate it. I
It's
go,
not so much the numbers, it's the x and the
yeah.
combining the exponent.
It's a process. That's why I say that's, again, this is my big thing on like, why should you write it yourself? Because otherwise you're just watching me do it and it's like real easy to watch somebody else. Like I watch people play pro basketball all the time. Put me out on that court, watch me get dunked on.
That's the point.
I just don't understand. Like, are there always going to be 3 numbers?
No, it could be 10 numbers.
So how would I do it with?
Well, I could show you a lot more numbers there, but there'd be a lot more work. I'm trying to keep it simple in the beginning. Trust me, this gets uglier.
It does? That's really ugly.
It's ugly because this is the first time you've seen it. Trust me, remember, like if you could think back to that first time you learned log and division, it was a horrible day for you. Like it was a horrible day for almost all kids. It's a very frustrating day, and this is a very frustrating day too. However, hopefully it's a little bit easier because you already know some things that you can apply to this. It's just like, wow, that's a lot of steps, and wait, what do I do here?
It looks overcomplicated.
If I skip
when
a
you
step,
actually
I
do
feel
it,
like I'm
it's
gonna mess
easy.
everything up.
That's everything in math, bro.
That's everything in life. Listen, when we do stuff, you're like, sure, I can mess this up. Look, I talk in front of young minds all day, and any mistake I make gets recorded on YouTube, goes out for everyone to listen to my mistake over, and I could possibly wreck all your futures by not giving you the right. You know what? I can't worry about that. I go, like, we make mistakes. That's it. Like, that's it. I make mistakes too. Like, we make mistakes. That's how it is. Nothing to worry about. And it's like, I'm never going to crack on you guys for, like, not getting something right.
Like then again, you were teaching like one bad mistake you do kind of influences our lives.
That's what I mean. It's way worse when I make mistakes than when you make mistakes. People are like, whoa, bro, why? Of course I'm making mistakes. I'm just learning this. You do this all day. You shouldn't be making mistakes. You're right. I probably shouldn't be. But it's going to happen. I'm human too. Yes, ma'am.
For what you wrote for a -4 minus,
We just didn't finish.
no, but isn't that supposed to be, like, the answer would be 2?
Nope.
Oh.
Wait, so how would that?
Okay, these two things are exactly the same. Mathematically speaking,
It would be 6, right? No,
-6.
So the
what? Yeah, it's
No.
-6.
No,
Negative
you
4
subtract,
or it's -6, right?
by the way, these two things, just to be clear, and I'm not messing with you, these two things are exactly the same. They equal the exact same, they are the same thing.
So -6. You multiply negative by a positive, it's a negative. So it's negative.
Exactly, so if
Because
you
you
would
add
make a
them,
positive and
it's
negative, you would subtract.
So it is -6. It's -6.
It's -6.
Okay.
Yeah. So here's the thing. I get, if you are somebody who struggles with, like, what do I do when I subtract these things? What do I do when I add them? Then I can easily help you with that. But let's not do that now. Then you come see me after school. You come me before school. We'll sit down together and I will gladly work with you those. But you have to give me that time to actually work with you. I will help you fix that. No problem. But I do need the time to sit with you to do that. I can't just magically fix that in 2 seconds. So we've got -6, -4. Worst case scenario, if you're like, wait, that doesn't make sense to me. Here's 0, here's -4. If I were to subtract 2, that means go 2 to the left. 1, 2, which would be -6, if that helps out. Okay, so now we've got -6. What is my next step?
We're gonna,
That's
x
the
plus,
remainder.
That's the remainder. Why did you know that was the remainder?
Because there's nothing left to bring down.
There's nothing left to bring down. So here comes the big moment where you show what you know. How do I write this answer?
x
That's
negative
minus
6 over x plus 2.
Beautiful. I couldn't do that any better myself. That's as good as it gets. That's exactly the answer, 100%. Dana, you ready to be thrown under the bus? We'll do this together.
I don't really have a choice.
You're right, you don't, but I appreciate that you recognize that. All right, we've got x squared minus x plus 3 divided by x plus 1. We'll make this the last one that we do today. Yes, sir?
is it possible for like a problem not to have a remainder?
Yes.
Okay.
But it's always better to do the ones with the remainder because they are harder than the ones without a remainder.
I was doing homework and it was like I got an answer where I didn't get
Yeah, it actually happens all the time that they don't have remainders, probably just as frequently as they do have remainders. The thing is that it's just the ones with remainders are the ones that people tend to mess up, so it's better to see examples with remainders.
It would be the same. That would just be the answer.
You just wouldn't have a remainder. If it ends up as 0, no remainder. All right, Dana, talk to me about what you know. Talk to me about the things that you're like, okay, I think we do this first.
Well, I would divide like x squared by x.
Okay, and right, we know. And what that means is when we are dividing x squared by x, what we're saying is x times what would give me x squared?
It would be x.
Okay, so it's x. So x times x would give me x squared. That's perfect. Now, once we had something up top, what did we do with it?
Wouldn't you
Go.
Oh, okay.
You got it. No, I'm not saying. I'm saying you're on it. Go, roll with it. You're doing great.
X times x.
X times x is.
Put it underneath the
So what is x times x?
x squared.
X squared. And then
And then, I would subtract it.
close.
Oh, I have to do 1 now.
Okay, x times 1
Which would be x. 1x.
would just be 1x or x.
Okay. And then I would subtract it.
Okay, now be careful here. Subtract both of them. So like we've got x squared minus x squared, which gives me 0. By the way, if you don't end up with 0 as that first one, something went wrong.
And then negative 2x.
And then we've got negative x minus a positive x becomes negative 2x.
Okay.
Now I get that this is the part that's getting some people, but then your problem's not with division. Your problem was with adding and subtracting positive and negative numbers. Not you. I'm saying in general. I know other people are like, wait, isn't that something else? If you're about to say that to me, then come see me after school. We'll talk about these because then you're having a different problem.
I understand everything until that point.
Okay, in division, once after I do the subtraction, what do I do
Bring
next?
down the number.
We bring down the number.
Okay, and then do I divide like 3 by x or
We say, how many times does x go into negative 2x, or x times what would give me negative 2x?
Yeah.
Yeah, negative 2.
-2.
I'm going to clear away some of these lines just so it doesn't get all busy up here. I'm just taking these away because we already used them, keeping it as nice and clean as I can.
Okay, and then I would do like -2 times x, which gives -2x. So opposite. Like, yeah. Oh no, I have to do something with the 1. This is a part of difference.
Okay, so what did you do last time with the number up top? Same thing. We multiplied it times the x, and then there were 2 arrows up top. There were always,
Then we did the same thing.
with what? Negative 2 times what?
Times 1.
Times 1. And what is negative 2 times 1?
-2.
Negative 2 minus a negative 2 is what?
5.
Negative 2
Oh wait, I was
x
doing 3.
minus a negative 2x.
0.
0.
And then the other one would be 5.
And the other one, we've got 3 minus negative 2 becomes 5. Okay.
So then I would write, I bring the 5 up there.
What is the 5?
The remainder.
This is the remainder.
So then I put
So how do I write my answer now? Now that we're at remainder, we're done. We just need to know how to write the answer.
be x minus 2 and then 5 over x plus 1.
There's only one teeny tiny thing that I would change here that I go, everything is perfect. But I said you can't have two things just sitting next to each other like that without a symbol in between.
Plus.
There needs to be a plus 5. Plus 5 over x plus 1. Dana, that was perfect. That's exactly what you need to do every single time. All right. This is why I decided not to make half due tomorrow and half due on Monday. It's better to just say, work on what you can of the homework and get as much done. We're going to go over the lesson more tomorrow. We're not learning anything new tomorrow. We're going to do more examples of this tomorrow, more practice on it. So that's what we're going to do. So try the homework problems. Get as many as you can done. If you're feeling comfortable with this, fantastic. If not, we'll do more tomorrow. But by tomorrow, we've got to have this down. Yes, ma'am. There's nothing due tomorrow. The homework assignment is due Monday.
Oh,
But it's all of them due Monday. Yes, ma'am.
tomorrow's an early release. What time is?
I don't know. They send you guys the things. I don't know.
No, I want.
Grace tried it.